So now we're going to take a short look at a inverting comparator made with an op amp. Right there, we got the LM358. So I got half the supply voltage set. We are higher than that, and we have a low output. You can see it goes to the positive supply, so we know that it is a low output, basically ground connected over there at the output. We lower the trim pot below halfway because that's what we set, and the red LED lights up. It's negative up there, so we know the output is high. So low voltage input, high output, and high input right there is low output. That's an inverted comparator. So now we will take a look at the schematic diagram I drew for the inverting comparator made with an op amp. Right here we're using the LM358. We were zoomed back for those watching shorts. So we set a reference voltage. Now we're setting that to the plus input. Pay attention, it's higher on the schematic here. It's actually lower on the physical component. You got to pay attention to where the placement is. And we got a reference voltage, we got our changing voltage. The output wants to be more like the reference voltage. Since there's no feedback, it either goes to the positive supply the best that it can, or to the negative supply, which it does better right there. And you can see we got blue LED lights up when the output's low, connected to ground, and the red LED lights up when the output is to the positive supply. Hopefully that makes sense, and I drew a little pin layout right there. And of course you got to power it, and then there's one op amp on the left side, one op amp on the right side of this integrated circuit. So now for these relatively simple circuits, I like to take a short time to look at the voltages. So we zoomed back for those actually watching the short. So we're using 5 volts to power this. You don't always see that on the schematics, and it's also powering the loads right there. It makes things simple when you got the same voltage powering everything. And so they don't always show those power pins on the schematic right there. So, in any case, it makes pretty good connection to ground when the output's low, and not as good of a connection to 5 volts, but you know, it does connect 5 volts. You got some transistors, so you lose voltage across the way. But yeah, there you can see pin number 8 right there is the positive supply. It also comes across, and whatever is positive there is basically a direct connection. And then pin number 4 down here is the negative supply. And we got an op amp up there and an op amp down there. And again, I'm using 5 volts to power this whole circuit. So now we're going to focus on our reference voltage. So I'm zoomed back for those that are actually watching shorts. And I split these up into shorts. That's what people seem to like. So in any case, we got a fixed value voltage divider there for half the supply voltage. We could use any resistance we want, but I want to set half the supply voltage to make things easy right there. Now it's going to the plus input. Be aware that the plus input is lower on the actual component than it is on my drawing right there. So I could draw on it either way, but for whatever reason, that's the way that I drew it. So over here, you can see we got our 2 fixed value resistors to the 3rd pin down. And of course, a comparator circuit needs a reference voltage, and then the changing voltage is compared with it, and that determines the output. And since we are inverting, that means our signal is to the plus input. The output's going to be more like our reference voltage. So now we're going to look at our signal voltage for the inverting comparator right here. So the reason why it's inverting comparator is because our signal goes to the minus input, the inverting input, which is lower on the schematic just because of the way that I drew it. But on the physical component, if you're using an LM358, it's always higher. Be aware of that. So in any case, it's whatever the changing voltage is, and you wouldn't use a trim pot in the real world, but you'd have some kind of voltage divider where the voltage slides up or down. You get a higher voltage in than what you set at your reference voltage there, you'll get a low output. You get down lower right there, you'll get a high output. We mentioned that before, and we'll cover that a little bit more coming up. But yeah, there we got our trim pot, adjustable voltage divider, full supply voltage across it, and a wiper that is making it to pin 2 up there, the non-inverting input or plus. So now I'd like to end these shorts with what the output is doing right there. So we got a couple LEDs, and I went back for those watching the short so they could see the whole thing. But in any case, blue LED, you can see the output is connected to the cathode, and then we have it headed to the positive supply. You got to put it in the right way or it won't light up. So it lights up when the output's low. It makes a pretty good connection to ground right there. We got a 1000 ohm resistor, also because blue LEDs are pretty bright. red LED, we got the anode to the output. So when the output is high there, positive supply, it will light up. 220 ohm, lower value resistor because LEDs, red LEDs are not as bright as blue LEDs, and also it doesn't output the full 5 volts. You lose a little bit in the transistors, just the way it's designed. So you can see we got a low output that has to be going to ground for the blue LED to light up. Make sure you put it in the right way. Long lead anode towards more positive. And then we got negative down there, so you know that you have to have the positive coming out of the output for the red LED to light up.